All right, I think we can go ahead and get started, everyone. So we have about 20 people on Zoom and about a dozen people in person, which I think awesome turnout here. So welcome everyone to the first speaker series for the semester for CACR. Scott's running a few minutes late, so he asked me to go ahead and DJ while he's coming in. So hopefully I can do a good job filling in, but those are really big shoes to fill in there. So it gives me great pleasure to introduce our speaker here today, Dr. Hyrum Anderson. Dr. Hyrum Anderson is a distinguished engineer at Robust Intelligence, where he focuses a lot on developing solutions to promote the integrity of machine learning systems. Dr. Anderson graduated with his PhD in electrical engineering, specifically focusing on machine learning and signal processing from the University of Washington, and MS and BS degrees in electrical engineering from Brigham Young University as well. He was prior to joining Robust Intelligence, he was part of Microsoft's first AI Red Team exercises, and also founded the Microsoft AI Red Team to help assess the security and privacy of deployed ML systems. So this is a very new group that was part of Microsoft's mission to try and help secure machine learning systems. He was a chief scientist at Endgame and a principal researcher at Mandia, and he conducted quite a bit of work in applied machine learning for information security applications as well. He's also served on the principal staff and associate staff for Sandia National Labs, MIT Linker Labs, and so on. And one of the things that I really appreciate about Hyrum, and one of his big claim to fame, is that he's very much of a person that wants to help develop the community of people that are looking at machine learning for security, as well as security for machine learning as well. And so to this end, he's done a lot of work in terms of doing a lot of public competitions around this topic. So malware evasion competition, phishing evasion competition, and so on. And what I find really beautiful about this is that it really encourages a lot of students to get involved into machine learning and security for ML in ways that they may not have been able to do so before there. He also co-founded, is on the board of directors for Conference on Applied Machine Learning for Information Security, which is a great conference that convenes a lot of practitioners, a lot of academics, a lot of people in government that are focused in on that unique intersection of machine learning and security, again, from the machine learning for security applications and security for ML side as well. So I'm absolutely thrilled that Hyrum is able to join us here today. His talk is going to be really interesting, going to give us a great overview of machine learning security, both from a foundational point of view and from a future point of view as well. And I would be remiss if I didn't ask our fearless director to say a couple of words as well. So Dr. Scott Shackelford.
Thanks so much, Sagar. Good to see you all. Welcome. I'm sorry to run a few minutes late here. Got to love the long faculty review committee meetings. This is going to be a really gangbuster CACR speaker series this year, in part because we're celebrating the 20th anniversary of the founding of CACR this coming spring. So expect some special programming. Really great to see you all in person. Thanks for being here, and thanks for kicking us off with such an outstanding speaker. Much appreciated. So looking forward to this. This is great. Thank you, Sagar, for doing such a great introduction. Absolutely.
Thank you, Scott, and thank you, Sagar. I just want to point out, I have a really funny picture of Sagar where we ran out of water at a CAMLS conference. So Sagar was pushing a shopping cart through a high-rise building full of water that we had purchased at the local, I think, Walgreens or something. To take the flight of service. Anyway, thanks to Sagar for being so involved and elevating this community in a way that is very much appreciated. I'm really honored to be with you today. I'm going to talk about machine learning security. And I'm going to give you the bottom line up front. You know, AI is everywhere, and this is a new threat surface that I think is relatively underappreciated. And there are ways for every one of you, be you a computer scientist, a lawyer, a business person, to be involved in shaping what the security of machine learning looks like. So let me start with a few anecdotes and notes. One way to measure the progress of machine learning adoption is by how much money people are spending on it. And it follows somewhat of a Moore's law, doubling the revenue of machine learning software development every 18 months. The business analysts company CB Insights noted that 6,000 public companies mention AI as important to their strategy going forward in their releases. So AI is in the world in ways that you would expect, of course, in consumer electronics, including self-driving cars, but also in many things that you wouldn't expect. For example, in skincare. to dial in just the right tone for your special blend and color of face. As well as, AI is in the world in the sense that, the Hershey's, who makes Twizzlers, actually uses AI using 60 million measurements of Twizzler candy to dial in just the right number of twists in the Twizzler candy. There are actually really important reasons for this, apparently, including the reducing the variability in the weight so they can maximize shipping and reduce waste. AI eats the world in other ways, to train a large language model today that we've come to love and appreciate. It consumes enough energy to power 3 average households for an entire year to train one model. And but what you get from that are really stunning things like GitHub Copilot. GitHub Copilot has anybody used that? If you haven't, it's amazing. If you code, it completes not just your sentence, it will complete your function and do it many times correctly, many times incorrectly, but will complete it based on code it's read on open source GitHub. And this is based on one of these large language models that took so long to build. So AI is eating the world in that it can also produce images based on a text description. Has anybody played with any of the mini diffusion models that is all the rage on Twitter? This one, I'm sad to say, is a very poor one. It rendered you in a very unpleasant form, but nonetheless did the best.
The colors are all right, though.
The colors are right.
all good.
The colors are right. Now, apparently, because I use the word, I think, hacker student, predominantly male with thick-rimmed glasses. So these are impressive models. But even though AI is in the world, it also regularly fails, and it does it not just a little, but a lot, and not just to kind of the AI plebeians or the inexperienced, but it does it in very mature companies with very mature security organizations, very mature machine learning engineering teams. So I'm going to walk through some of that today. The reason that this represents a new attack surface is because we're not only relying on software, but we have these other dependencies in the data sets, in training code. And we don't actually specify what the model is doing. We let the model figure that out from its training procedure. And so that results in a number of traditional software vulnerabilities, of course, but also it yields unexpected model behavior that can be difficult to predict. It has corner case inputs can cause problems. It can actually leak some intellectual property. I'll show you that a little bit. And it is prone to manipulation. And I'll, for those who haven't seen that, we'll introduce that just a little bit also. So the first thing I want to point out is that I'm going to cover like 4 major classes of where this security risk is involved today. And then we're going to talk about what information security professionals can do to help shore up a foundation, and then how each of us can be involved in shaping the future of AI. So the first kind of thing that I think is really important is that I have been a data scientist, so I can say this only pointing a finger at myself, is that machine learning engineers and data scientists get a pass when it comes to security. We're special snowflakes. We have special computers. We have special domains that are over permissive, and we need it to develop our cool models. And this happens in large and small organizations for good reasons and bad. Good reasons include that we need GPUs, and GPU machines are different than the regular. But let me just tell you what a ramification of that process is. In Microsoft's very first AI Red Team exercise in early 2020, we went after a system that was built internally to provision cloud resources. So think about it as a model that would predict how to best utilize computing resources. Kind of a big deal, because at the scale of Microsoft, with 150,000 employees using these resources, getting just a few % efficiency gain is tens of millions of dollars, right? So machine learning model is responsible for this optimal resource utilization, and we attacked it. A couple of things to know about the model. The model is internal only. There's no public facing access. It's, maybe it's secure because we can't find it or can't see it. Second thing, this has nothing to do with security. It's not fraud, it's not abuse, it's not detecting malware. It's just predicting, how do I place a workload on physical hardware? Nevertheless, using mostly tried and true red team principles, we can fool this model. Let me explain what I mean. So we got internal access to this. We found overprivileged data and overprivileged code used to train the model. This maybe isn't alarming to you, but many people would say, let me steal the model through some clever algorithmic trick. No need. The model is actually here, and we can train our own. And much like you would maybe do a brute force password attack offline, we can take that model and brute force it offline, where nobody can observe what we're doing, find the inputs that would cause the most damage. Those are called the evasive variants. Then we request a new account. We take these evasive variants, we ask for them in the real live service, and now we can cause a noisy neighbor attack and a denial of service. So the lessons learned from this, that machine learning developers and those shaping the policies, security policies around those teams, include the fact that non-security models can have an outsized security, especially those models can have an outsized security impact because nobody is thinking about security. The second is that internal models do not make them secure. Internal models also need robust testing. And the third thing is that, and a real point is that foundationally, fundamental cybersecurity is probably the most important element for machine learning security. Fortunately, we've been working on that now for a long time. We just need to practice what we preach in that domain. Okay, a second, and I'm gonna move from least novel to maybe most novel of these threats. A second class of vulnerabilities that machine learning introduces us to are a whole host of supply chain vulnerabilities. We rely on data that's mostly scraped from the web. We rely on models, sometimes from open source repositories. We rely on we can actually grab those models from sight unseen, not having trained them ourselves, but use somebody else's model more and more these days. As I know Ben has studied, there are a number of vulnerabilities common to the software we use to build our AI systems today. That is growing, or maybe not growing dramatically, but we're discovering them at an increased pace. In addition, the software itself can be, you can upload almost anything to PyPy that serves packages. And several times a year, PyPy will release, we found malware in your package. If you pip install this, it will open up a remote access tool on your machine, right? So these come in the supply chain dependency of machine learning models. Another one that's maybe not appreciated is that we store our data and our models, the weights of those models, in file formats that often rely on serialization that allows arbitrary code execution. So one example of that is you can try this today on your laptop. To demonstrate this, I promise no actual harm will come to you, but Hugging Face is kind of like the GitHub of machine learning, where you can have access to something like 80,000 models that have been pre-trained. And with a simple API, I can go find a model, and with a very simple API, a few lines of code, I can use that model. Now, this model I've doctored to execute arbitrary code. It's doing what looks to be scary, but is actually just some benign web page that I've opened in a browser. But you might not know. If this were silent, this could open up a remote access tool. The model itself is still totally functional. So this dependency of the file formats that we rely on, and we really pretty much don't check today, represents a vulnerability that is relatively new and introduced by machine learning. A third class of attacks and vulnerabilities for machine learning are actual attacks that happen in the wild that are mostly trivial in nature. And I'll describe two of them. You've probably heard of Microsoft Tay. Tay was supposed to be a sweet 16-year-old bot introduced in 2016. The number 16 will come up a lot because it was taken down in 16 hours after quickly becoming a racist bigot by people interacting with the bot on Twitter. So there was nobody who did this had a math PhD. It just was the crudeness of crowds, the kind of the Reddit and Twitter influence that overwhelmed the bot with data and quickly turned it into something that was creating inappropriate content. So this model learned from interactions. That's probably not a good idea. And it was very easy to do what we'll call an indiscriminate attack. It's not sophisticated. It's just kind of more data that can handle. Another, speaking of Twitter, another interesting use case is Twitter uses machine learning for its content moderation to find bots, to find inappropriate content, that you might not want to view this post, or this post, we can't verify the authenticity of this post. Those are good things. They're incredibly easy to evade. This is from a Chinese propagandist during the whole Uyghur propaganda campaign that was allowed to, the bot was not detected, even though the content is almost identical, by appending just the right few characters at the end of the tweet. The machine learning model was unable to identify them as having come from the same source. So this is very easy to do. This did not take much, but nevertheless, content moderation was evaded. The last class is probably what's most relevant and has the most energy in academic research today. And it's this class of algorithmic attacks that we study in machine learning. And these I will call sophisticated in that they require some element of optimization, either with access to a model, but in many cases without direct access to the model and weights. And they can cause a number of security violations. For example, researchers showed that with access to the model, they can invert the model. So given the outputs to a model, can I invert and figure out what training points were used to train the model? So that, of course, would be a privacy violation of private training data. And to date, the best are providing kind of an approximation of training points. Another kind of intellectual property privacy violation is that these models can readily be stolen. This happened actually in 2019 when GPT-2 was being released. It was OpenAI crowed about it, but did not release it and promised a release after they had figured out the safety policies. Well, research didn't like that. So they got API access to the model. They submitted a bunch of inputs, recorded the outputs, and used those inputs to outputs to train their own and release it. And think about, GPT, OpenAI is a for-profit company. This actually means lost revenue because somebody can go to an open source version. Another class of attacks I find incredibly interesting is researchers at the University of Toronto showed that with Azure, with deployed machine learning models, they can just algorithmically discover just the right input that will cost Azure the most money. So think about a machine learning model with all the math that's happening. Not all branches are necessarily taken, but they were able to discover what computation graph, what graph would maximize computation, what input would cause that to happen. So I thought it was a very clever input, causing now kind of a denial of service or a loss of quality in service. So, I call these sophisticated, but this is something that even if you've never seen, you can do by yourself with relatively few clicks or with code that you've downloaded. In this example, to change this image of a stop sign into a speed limit sign. And the other thing that I find interesting is this is not restricted to like the pixel domain, is that the same sort of attack can also be used for, on real stop signs involving real vehicles and real cars to cause a stop sign to look like speed limit sign. And the ramifications of that are obvious. So this is work by Ivan Eftimov at the University of Washington called the sticker attack, where just a few stickers that might to you look like weird graffiti are placed on a stop sign that now they can target now what they want this to be seen as to, you know, the Tesla being driven. So let's put it all together. As we're building a machine learning model, and we have a pipeline for this, we have a data curation phase, a model training phase, model validation, model deployment, model monitoring, and it's all built on top of a software stack. There's all of these violations that can happen at almost every step, in poisoning, in arbitrary code execution from a model supply chain, backdoors that could happen within the model itself. And even after deployment, you know, even after we've delivered a model, then there's a number of things we can do to, you know, abuse, evade, misuse, cause evasion, attacks, etc. So there is risk in AI, and one thing that the cybersecurity community can do is help the machine learning community understand and tackle risk. And it's kind of, you know, still woefully underappreciated in the machine learning community how much of this has been done in security. So one great contribution in recent years has been a threat model thinking when people are deploying machine learning. So briefly, in this threat model for machine learning, we talk about attacker objective, and here you can see for the information security people, the standard CIA objectives and confidentiality, integrity, and availability attacks. Attacker knowledge, where we can know close to nothing to having a full specification, a full knowledge about the model being attacked, and the influence. So the capability, we can maybe do this in an exploratory way. That means I can probe the model and discover post hoc, or I can do it causative. I can affect its supply chain or its training process in some way. So just for practice, you know, all of these that I mentioned, you can already make a contribution to machine learning by putting a name and a threat model to the kind of attack that will help machine learning researchers understand in what settings their contribution should be considered risky. So an example of this is, you know, all of these software stack attacks are black box causative and almost any violation you would want, right? In these triviality attacks, this first poisoning attack is a causative integrity attack, causing the model to go south by feeding it new data. And in the Twitter case, this was a exploratory integrity attack, right? There was somebody discovered without affecting the model how to evade it. In these algorithmic attacks, we have a exploratory confidentiality attack when I can invert that model and uncover the private training data. We have an exploratory confidentiality attack when I steal a model that was supposed to be intellectual property. And we have an exploratory availability attack in this thing that's called sponge examples. So causing the availability of a system to go down. This alone is new to machine learning adversarial researchers just in the last few years, and a contribution from cybersecurity community. So AI is in the world, but adopting AI also means adopting the AI risk. And I like to break this down into kind of 3 segments of risk. And we talk about the operational risk that is mostly benign, but happens especially when companies have many models. One customer I'm thinking of has tens, if not hundreds of thousands of models, one for every product, right? To predict how it's going to be sold or whatever. And there's operational risk involved in deploying and maintaining and monitoring those models. So there's a whole class of responsible AI risk that involves safe and fair outcomes for people where their lives are affected by the output model. And there's a bunch of legislation we can talk about that's especially addressing this area. This last piece of the pie, the security and privacy, what we're largely focusing on today, is about a threat-centric protection. There are threats today against machine learning. The ones that we talked about mostly are research, the algorithmic style, or happen by people who don't even know they're attacking machine learning. they're guessing and they're checking, but they are evading and causing integrity violations, mostly, or some privacy violations to machine learning models. So with these three pieces of pie of AI risk, I want to talk about how we're addressing this risk and invite you all to participate in this process going forward. It's not just for technology people, it's also for people interested in policy and government and compliance and risk and business. And I hope that as we cover some of these recent developments, that you'll find something that you want to latch onto, and you'll become an expert in that, and you'll help to pave the way for more secure AI. So I've listed these, like if you were taking a policy class, you might start with the least invasive and end with the most invasive. And that's how I presented them here. Technology perhaps is the easiest thing for us to do. Bottom line up front is I don't believe that technology alone is going to help us manage our risk. We're going to need pieces of each of these, but we'll dive into each of these briefly. So first, technology solutions to AI risk management. Okay, so if I have a machine learning model that I think can be attacked, what technology solutions are there that can help me to manage the risk or prevent an attack or detect it in some way? And for the next few slides, I'm going to be using this example that's come to iconify adversarial machine learning attacks. That is a cat that is recognized as guacamole with very few pixel changes. So the icon, if you've not seen this, you will now. You'll never you can't unsee this now, and you'll see it everywhere. But so the first thing you can do, there's been lots of work on, is you can try to detect adversarial examples. So think about this as a firewall that sits in front of your hosted online service. It's a web application firewall that observes an input, inspects it for whatever, and decides whether or not to approve, deny, block that request. Actually, at Robust Intelligence, we have the ability to impute. So if I see something bad about the image or about, say the tabular feature, we can impute a missing feature and still pass it on. There are ways to do this. Now, the main criticism of this approach is that, okay, so here's an AI system that I know can be evaded by just the right attack. Well, what's this? Isn't that an AI system too? And can it be evaded? Right? And the answer is absolutely. It absolutely can be evaded. As another great contribution from cybersecurity to the machine learning community that is not yet appreciated is when somebody brings this up to you, I want to ask them if they have anti-malware on their laptop, right? And they should, even though you can evade that very easily. You can land malware. It does serve a function to raise the cost to an attacker. So detection schemes are deeply flawed in that they can be evaded, but they can. These are the antivirus of machine learning inputs. The firewall that can be evaded can also raise the cost to an attacker. A second general strategy. Oh, let me first motivate. Like, why do we think we can detect these at all? Well, let me show you what an attack looks like in the data. So over here, you see nominal behavior, just observing the model output. This is a model that is detecting a certain attribute of financial activity of a binary classifier, where the activity is pretty split half and half, 0 or 1, right? So here's normal behavior, and here's what happens when I attacked it. So you can right away, without even understanding anything about what the attack is doing, you immediately recognize that this is not normal. And second, you can actually break down an attack into these various phases. There is a fuzzy phase here. That's discovery. It is an algorithm probing your model about the best place to start an attack. And then there's a phase that we'll call the exploration phase. Now that it's found a starting point, it's kind of trying to optimize and refine its attack. And then in the end, it's found the right input to your model in this exploratory attack, and it can use it. So you can, this might be difficult to detect, but these signatures are very loud, very high signal to noise, and there are ways to detect them. So, great. If anybody's interested in this, I'm happy to dive deep, maybe offline, about these approaches. Okay, a second kind of way you might think to defend yourself against an adversary with a technology piece is to hide or obfuscate something about your model. So all of these models, all of these adversarial attacks, these algorithmic ones are iterative in nature. They require feedback. So if you can somehow provide bad feedback, you might at least frustrate the attacker. And that can be done in a number of ways. I can add noise to the input or the output, or I can do other things. People have even proposed, let me not train a model on the image data, but on its, I'm going to encrypt the images first and then train it. And that causes what that does is it makes it very difficult to estimate gradients in the system. And so this is a fine idea. Again, the main criticism here is that all that is happening here in this defense is it's creating, and credit to Nicholas Carlini for these plots. All of it's doing is if this is my, if this is my cat and this is guacamole over here, all that it's doing is taking this energy decision surface and it's making it not smooth. So that if I'm an attacker, locally, it's difficult for me to tell which way is guacamole. I'm stuck in I can't see the forest for the trees. But if you're just a little bit more clever, with a little more expense, a little more clever ways to attack this, you can zoom out and see the forest for the trees with some smoothing techniques. So this is also not impervious to attack, but might raise costs to an attacker. And a third, and maybe the one that most are familiar with, is called adversarial training. And it's a way to inoculate your machine learning model. Essentially, what you do is you attack it. And then when you have these examples of inputs that now look like guacamole, you say, no, that's actually not guacamole. Feed that back into the training set. This is your inoculation against confusing cats and guacamole in the future. And this can raise the cost to attacker. What this really does, if we reflect on that decision surface, is it makes a very pessimistic model who is unsure about anything in life. And where this model was very sure that this was a cat, probably a cat, I don't know. And then everything this way is definitely not a cat. So this is a very cautious model that does, in many cases, decrease the nominal performance of the model at the expense of, of course, having more robustness. Okay, technology solutions alone are imperfect. They raise the cost, but do not prevent. Secondly, they're actually kind of a pain to implement. So if I'm a machine learning model developer, what incentive do I have to do this? My reputation, maybe, or there's not a big carrot except at very big companies, mostly around reputational risk and responsible AI risk. So as we move down the risk management, let's also investigate kind of what industry could do to ensure that this is kind of there's regular testing and regular development that's secure. So I mentioned early on that I was involved in founding the Microsoft AI Red team and did the first test there. Before Microsoft came along, and since, there's been a sprouting of red teams in the last several years. And this is a good thing. You'll notice that these are all kind of giant companies, mostly worried about their image, right? And so in this sense, these companies are mostly testing models based on their bias or fairness or embarrassing misclassifications or embarrassing data leakage that could cause harm or abuse to users or reputational damage to the company. And so you can go today and find lots of some information, at least, about Microsoft, Twitter, Google, OpenAI, Meta, who all have these teams who are deliberately attacking internal products, either before release or after release. This is a great thing. And it exists at, at least 5 companies out of the 6,000 public companies who are developing AI for their own public good. One interesting thing to consider is that, if you look under your alarm clock or your toaster, you'll probably see this symbol that says that a laboratory has tested your product for safety. And nothing like this today exists for machine learning. This has been around since 1893 or something. Unlimited laboratories who do this product specific testing. They're a third party. They have no investment in the products being tested, and they provide a stamp. Importantly, is that there's no law that requires a company or a product to get this endorsement, but it might give a consumer just a little bit of comfort knowing that their lamp won't catch on fire or their toaster won't ignite whatever's in there. So one thing to consider is how would we motivate something like this to provide some kind of third-party testing to those companies who can't afford to host their own AI red team. So I'll let you think on that for a while. One other interesting thing is that industries, sometimes corporations in a particular industry can benefit from so-called co-opetition. So in 2019, I believe, or 18, the partnership on AI was formed, including founding members at Google and Microsoft and others. When AI is concerned and you're not including China, it's an incomplete picture. And so in 2019, Baidu joined, but sadly, because of politics, they left in 2020. And so this kind of co-opetition that allows industries to work together to develop these standards and norms is also a struggle, something that we could use our business leaders help with. Lastly, kind of the maybe most invasive is government standards and regulation. Like, what can we do if technology alone fails us, if industries are not self-motivated to do this? Is it okay to have government involved? And if so, what's the right way to do that wouldn't cause damage? So the important thing to note is that actually regulations on AI are already here. And I'm just curious if anybody has heard of them or run across them. I will introduce 4 to you today. So these I think are, this is like the tip of the iceberg under what's coming. The first has been around a very long time for financial institutions by the Federal Reserve. It regulates models, probably even before models were machine learning models, but statistical models in finance that regulate that these models should be disciplined, knowledge-based, and properly implemented, called SR 11.7. More recently, we have had the OSFI guideline E23 that specifically talks about model risk at the enterprise level, also for financial institutions. So, if your bank is to be FFRDC, it is to be federally insured, then it needs to be able to satisfy some of these guidelines by the Federal Reserve, by OSFI. Recently, New York City hiring law was passed that specifically mentions that that automated employment decisions, so machines that read resumes, must be evaluated by an impartial evaluation by an independent auditor. And this is going to affect in January. So this is specifically addressing AI for those companies, most companies, big companies that use kind of filtering by AI needs to have some human oversight. And lastly, I think is a big one is the EU AI Act. The EU AI Act is going to come probably in the first part of 2023. It's in proposal mode, draft mode right now. And it addresses mostly large companies, mainly focused on the public sector of AI in the European Union. But if you think about the so-called Brussels effect. Do you remember that GDPR is a EU law, but how many of you had to accept cookies in your browser today, right? In the United States, it's because of the so-called Brussels effect that a law passed in Brussels. It's too difficult for companies to maintain different platforms for different regions. So they raise the bar themselves and try to comply everywhere. So the EU AI Act is very likely to also cause repercussions for you here in the United States and elsewhere, where these will have mandatory security assessments. So, you know, is this a good thing or bad thing? I'll let you decide. But one thing that others have noted is that, especially this AI Act is going to be expensive. It's going to cause almost a 1/5 more spending for people developing AI models. So this is not unintrusive in any sense. It will cost essentially the EU economy $30 billion. One note from the UK National Cybersecurity Center is that they note that machine learning is important, but security is hard, and they would prefer to have guidance and principles over legislation. Okay, I'm wrapping up the last few slides here. I am a technology person, and I hope you can tell my passion is about the adversarial machine learning elements of this, but I do appreciate those who bring passion to especially the policy and the standard sides. We need more of it, and I'm hoping that this body can be among those that are taking part. I want to just make sure that you know that it's not going to be solved by adversarial machine learning researchers. I hope it's not. It'll be the wrong solution. Just like I hope it's not only solved by legislation. We kind of need to come together for this. So how can you begin to get involved and understand? If you're new to this security of AI, I invite you to do really simple things to become involved. One thing you can do is for the next, I think, 2 or 3 weeks, you can actually win money by participating in a pretty simple competition that tries to evade anti-phishing filters that are based on machine learning. And if you can find the right HTML tags to put in your web page and it evades it, then we're going to give you $3,000. And if you're a student, we'll also bring you to a conference, right? So this is a way for you to just dive in. The best way to get to know this industry is to do it, and this will take you every day of your long weekend to do it, but it'll be great. Another related competition is the Machine Learning Model Attribution Challenge, especially with the advent of these platform models and Hugging Face, and more and more development is going to happen not by you and I coding up a model, but by us borrowing a model and using it for our own purposes. You can imagine with the power that these models have, the potential for misinformation. The Machine Learning Model Attribution Challenge is designed to address this. Can I tell if I detect some misinformation online, what the provenance of that model is? Where did it come from? Whose model is it? Can they help me remediate? So this competition concludes in 2 weeks. We'll also give you $3,000 if you can guess. If I give you 10 models, can you guess where they came from based on you interacting with that model? So these are all generative text models. You give it a prompt, it will complete your sentence. Based on those idiosyncrasies, can you tell that that's actually GPT-3 under the hood, right? I'll also mention these conferences will also, if your students send you to one of these conferences, and these for anybody are great conferences to come to get to know at least the technical side of these issues. Something you can do today at Microsoft, our team produced this tool called Counterfeit. It was really just a wrapper intended for security professionals. So it's trying to abstract away kind of the math and allow you to attack your machine learning model, understand its weaknesses. And this is free. You can go to GitHub here. Two databases. One is called the AI Incident Database. This has 1,600 reports of AI failures and harms that's being maintained by a passionate crew that this number grows by about 200 every month of these failures. So if you are interested in this space and want data to collect to to motivate your need to work on this area, you can come here. The most recent report was just a few weeks ago with the crash Tesla. These mostly, by the way, are unintentional failure modes. So they're accidents that happen because of AI that was mostly because of policy gaps were used in a setting where safety problems could happen. The MITRE-ALICE framework, on the other hand, is all about intentional failure modes, an attacker causing your model harm, and they are cataloging case studies about those happening, and also trying to map out what techniques were used in an attack-a-kill chain. And for those familiar with the MITRE attack framework, this is meant to mirror kind of endpoint security, but for machine learning. You can also get to know some best practices. If you're a software developer or not interested in machine learning necessarily, there are practices out there. You should, when you go found a company or work for a big one, you should also help them to come up with best practices and guidance to make sure that when you develop AI systems, they're secure by design. This report that we released earlier this year is a risk assessment framework that helps you to especially conduct your own AI security risk assessments within the organization. One of the most important things that have happened in the last few years with respect to AI policy for the US government is the National Security Commission on AI, which has a whole chapter devoted to the security of machine learning. The report itself is about how does the United States get more serious about AI. And one of the recommendations is, let's fund it more, but also let's devote a bunch of funding to making sure we do it sensibly and securely. And so this is an easy report to read with a whole chapter on AI security. Lastly, I want to point out that mostly Ram, my colleague, is writing a book. I'm helping him. If you want to know like a much deeper dive about the material today, we are not getting anything from this. We just want people to know about these. This is not a technical book. This is intended for, my uncle's going to read it. My wife's going to read it. Hopefully she'll like it. And this will be filled with anecdotes and stories to motivate the need for a holistic approach to AI security. So with that, my summary is that AI is eating the world, and it will continue to do so as we build the appropriate foundations for a secure future. Adopting AI today means adopting AI risk, and we together can come up with a holistic risk management framework that includes technology and includes self-incentivization and includes the right kind of policies and legislation to make this happen. So thank you, and I'm happy. I thank you for having me today. I'm very happy to take questions or comments.
All right, we'll open it up for questions from the audience here. I'm going to go ahead and move over to Zoom and see if there's any questions. Here.
Just while folks are thinking, maybe I could just kick it off if that's okay. Such a fantastic presentation. I love it. Thank you. I'm so glad some students were able to enjoy that too. One area that I followed a little bit a few years ago was around autonomous vehicle regulation, kind of comparing how the US and the EU and back then China were trying to regulate and conceptualize the security threats in that space. So my knowledge is now about 2.5 years outdated, but I know you've been following this much more closely. Have there been any more developments in how the national highway transportation or any states?
Yeah, so far as I know, it's still state by state and kind of discombobulated a little bit.
Yeah.
So I don't know of any more developments than, Arizona has one way, and
that's right. Are any of the automobile manufacturers participating in those industry codes of conduct that you were? So it looked like just tech companies, but
yeah. So I don't believe that, for example, Tesla is involved in the AI Partnership Coalition.
Mm-hmm.
But that's something good to check. Yeah.
Yeah. No, fair enough. Thanks.
Yeah. Thanks, Scott.
Yeah.
The SR 11.7, I didn't know anything about it before, so I apologize. My question's way too basic. But is there evidence out there about how effective it's been, what the problems, or to what extent there were problems before, and then the extent to which it's addressed the problems?
I don't know. That's definitely not my forte. But that would be a great study, actually.
I tried to Google, I didn't find anything.
It would be a great study because like the best predictor of the future is probably the past.
Yeah.
But we've had something since 2011.
Right, that's why I think, yeah.
Like what does that say? Like maybe a longitudinal study shows that there's been no improvement, or maybe there's been a rapid one. Like we need to know. And if the people doing the EU AI Act don't understand, don't have that appreciation, that'd be an excellent contribution. I hope you're volunteering for that paper.
I didn't see any on Google Scholar just now when I tried to look.
Yeah.
Yeah, can you talk a little bit more about like IPsec? So I was following this a little bit. So someone was trying to apply for copyright for an image that we created using AI drawing. And the US Copyright Office essentially says it lacks human authorship, so we're not going to apply copyright to it.
Oh, I think copyright law is so fascinating. And I am not a lawyer. I don't know very much about copyright law, but so actually liability, even so there's two parts. I want to talk about copyright law and about liability. Copyright law, what is going to happen based on these generative models that are using in many cases copyright? They've tried to scrub out copyrighted content, but it's an impossible task with the size of the data set. What's going to happen to copyright law? There's an interesting talk about that maybe you've seen that shows somebody who gained the current copyright laws for music by copyrighting all of the 5-note motifs in an octave. Have you seen this before? So it's essentially every combination of 5 notes they put on a disk. All you need for copyright is to have a record of evidence. It all fit on a USB drive, and you submitted it to the Copyright Office. So that essentially every song ever is somehow infringing on his copyright, to show you how poor our current system is. That said, much more complicated is this fact of generative models spitting out text whose authors have made a best effort, an imperfect best effort to scrub it from copyrighted material. I think is a fascinating piece of law to study that is in a lot of flux right now. Do you have any more information about the state of that?
No, I was just looking into it. So I also came across this post, like where some like professional drawers were complaining about like drawing AI taking away their job, and they came up with a solution saying we should fed the AI with copyrighted material like Disney stuff. So it's going to generate things that look similar to Disney copyright stuff, and then we can stop the AI. I don't know, like, is that feasible? Like technically, like if you feed the algorithm all stuff like from Disney, is it just going to produce things that looks like Disney stuff?
Right, and then there's a copy versus resemblance that is probably going to be left up to a human interpreter to determine if that's an infringement, right? One technical challenge in all of this is, so for example, for Copilot, Copilot has been trained on all the public GitHub repositories that at least one time were public. They might not have been public on purpose. They might have supposed to have been private, and their license may have changed, right? There's all of these things to consider. So one thing, I know that is a challenge today is for these generative models that are used in code production. Obviously, if I'm using code let's say it's, it has an open source license. If that ends up in my code, I have to read all of my code. That's really bad news. So there's a lot of work done in checking the utterances of these models against a database of known code, which is an impossible task, right? The code is just growing without bound. One other piece about liability. So far as I know, so far as what I understand from folks that I've talked to in the US government, is it's the position of the US government that they are liable for the models that they serve, not the author of the model. So does that make sense? So like if I grab some model off a Hugging Face and it's got a vulnerability that can be exploited and cause harm, I, as the last endpoint before the customer, am the one that's liable. I don't know if that's pervasive in law, but I thought that was pretty interesting. Yeah. Great.
It's got a text saying chat's disabled for everyone.
Oh,
No,
There's
there's a reason.
a call.
so any way to quickly enable it?
Let's see if I can jump on.
All right, so Mark raised his hand, so we can see people raising their hands. Scott, are you hopping on this one?
I am hopping on now, but it looks like I'm just attending mode.
Oh, did you see that? I think you did it. Panelists can, attendees can chat with everyone.
Oh, there we go. Okay, try now.
Yeah, go ahead.
Yeah, so you mentioned that your AI firewall can detect adversarial data and kind of throw it away. Are there any applications for robust intelligence in which you guys actually formulate some synthetic data to feed into the models? And do you see that like having a broader role anywhere in general?
Do you mean synthetic data like the adversarial retraining, or more
Yeah.
generally to protect?
Like you know, you're filtering out, let's say you have a data set where your model is detecting that there's a lot that's really unusable. Do you do any sort of like recreation of data, like say, like through techniques like SMOTE and other?
Yeah, that has actually been something we've run across before. That sometimes the best way to protect data is to get rid of the real data.
Right.
Yeah, and use data synthesis. And it has, actually, I think it sometimes has mixed results, right?
Yeah.
Like you do sacrifice something in many ways. Of course, you can also do sort of that is not dissimilar from privacy preserving machine learning, where you just add noise to your data set. So the model is unable to latch on to specific instances in that data set. So those are, I think there's a dance and a balance there.
Right.
But we definitely at Robust Intelligence are interested in providing customers with those sorts of requirements.
So Hyrum, we have a question in chat. So a lot of organizations are still struggling to get value out of their data by building AI models. What are some suggestions to create awareness of security for AI models is built in?
Oh yeah, well, you're doing a great job by participating in this seminar series, this seminar. Awareness, I think, is our number one issue. I used to tell our team at Microsoft AI Red Team is that our main job is not attacking models. Our main job is teaching people about the security. And our second job is actually attacking and delivering value to the team. And so it's a huge one. I think that it's going to come naturally. So the reason I think that is that look at what is the pain distribution for AI? What's the history of the pain distribution? And what I mean by that is if you look at 2015, the biggest challenge for me was to develop, I wanted a cloud platform that could train a model of the size I wanted. That was the biggest pain point. Today, that is not a pain. Today, the pain is how do I do the operational part of that? How do I monitor the model? How do I keep track of it? In 2 years, that will not be a pain. The pain in 2 years is going to be all about risk. It's going to be about, okay, now that I built it, that was easy. Now that it's out there and I'm monitoring, that was easy. Oh my gosh, what have I done? And how do I manage the risk with this? That is going to be the best stick for people to get serious about. I think what's being suggested by Tim is this kind of shift left mentality to get it right the first time. And I love that thought, Tim.
Okay, so we have a couple more questions in the chat here. So the modifying of a stop sign seemed particularly simple and dangerous. Just curious if you know of stats on how often that has happened and if you knew of any or had any simple solutions to it.
Yeah, so far as I know, that has only happened in a laboratory setting. That was by a student at the University of Washington at the time. And so generally, most of those algorithmic attacks, there have been a few in the wild, but most of the algorithmic style have been by researchers, and they don't often happen. And the reason is there's actually much easier ways for an attacker to cause you harm than by writing a fancy math algorithm. And as we saw with Tay and the Twitter, like that's why you don't have to write the fancy algorithm. The sticker stop sign attack, actually requires a bit of math to know what size your sticker should be, what color, the placement. So it's not a simple attack to pull that one off.
So I think there is one more question that we can take. So we're right at the end of the session here. So Tay is used as an example as a security violation, but the model was set to learn from live interactions. To a data scientist, each input is an adversarial attack. To a cybersecurity professional, it's not an attack. The system is working as it was designed, but if not how it was intended to work. How can we move the two groups to a common understanding of security instead of having two different definitions?
Oh, that's a really great point. And I think it also speaks to a divide between unintentional and intentional failure modes, right? And I feel a little bit like the parable of the 7 blind men and the elephant, and we're all like filling a trunk, and we say it's a snake, we fill something else. We're all describing actually the same underlying concept about model robustness and model integrity, that models need to be tested. They need to be thoroughly tested before we release them, and not just in adversarial, but in like what can go wrong by weird corner cases in the wild. I totally agree with that sentiment. One last point is that if you look at the history of like threats against a nuclear power plant, the main threat is not a terrorist blowing it up. It's like what happens if a hurricane hits. That's what keeps people up at night. So the notion that unintentional failure modes are somehow less important is absolutely false. And we need to test everything, right? Test and robustify everything.
Great. Well, thank you, Hyrum. Thank you very much again. Scott, any last comments or thoughts on your side?
Well, this was terrific. So another round of applause for Hyrum.
Thanks, Sagar. Thank you for being such a wonderful host. And I neglected to thank as well, if everybody could thank Leslie and Diana and Tori for all of their hard work in putting this together.
Haven't signed any of the sign-in sheet,
Oh, yeah.
please do so, because we try to keep track of attendance.
All the metrics these days. That's right. Yeah. And a special another thanks to Vaughn as well for leading CACR so well in building out this series over the 11 years, and to Joe for running this series so effectively this year and in past years, of course, as well. So look forward to seeing you guys next time, next month, right?
Yeah, I think October 20th is it's a really nice follow on, because that one is called the security of open platforms. So I think you've started us off on the right
Oh,
direction.
I want to attend. It's great.
Thank you again.
All right, thank you.
Yeah, thank you all.
Well done.
I'm good. I've got it.